This week we will be talking about object-oriented programming. We've been doing programming, we've been doing some object-oriented programming, but we haven't really talked about what makes a programming language object-oriented. Object-oriented programming languages have 5 features that are common to them. The first is called abstraction. Abstraction is hiding details. In other words, being able to use something without knowing how it works. So we can drive a car even though we don't know what the inner workings of the car are. We know that we can push on the gas and go, and push on the brake and stop, and change the gears maybe, use the steering wheel, but we have no idea what's happening underneath the hood of the car, or most of us don't at least, to make it go. We've also been using game object functions, right? We can use them, but we don't know what the code looks like that's actually running the game object, making them work. So that is hiding the details of what's happening. We're able to use something without knowing how it works, abstraction. Next we have encapsulation. Encapsulation is putting data and methods into what we call a class together for an object, and kind of putting them in a little box, encapsulating them. So you have all the data that's associated to that object, and you have all the methods, which are the actions that work on that data, that change the data or use the data that's associated with that object. They're all put into a class and given a name, and you can then use them, and different classes can kind of talk to each other, but they're each encapsulated in their own little box. Next we have something called overloading. Overloading is where you can have two functions that have the same name but different number of parameters. A long time ago, when we had programming languages like C and Pascal and Fortran, those did not allow overloading. If you were going to define a function, you had to give it a name, and no other function could have that name. What overloading does in object-oriented programming is it allows you to have the same name twice, but you have to have different numbers of parameters. So that's what makes the function different. It's the number and types of parameters that are associated with that function. Also, object-oriented programming languages have a public interface. That means there are also functions that can be used outside of the class. And anything in the class is usually private, but you can make it public, and then other classes can use the functions in your class. And finally, we have what are called constructors. Constructors initialize an instance of the object. Basically what that does is it tells the compiler to give that variable that you're defining as that type of object, to give it enough memory to hold all of the information that's associated with the object. So if you have game object box equals new game object, basically game object with the open close parentheses here, that is the constructor. And so when you declare a variable of that type, the type is game obj, it's called box, we have to tell the compiler to give box all of the space that's needed to hold a game object. And we know that space associated with a game object is an x coordinate, a y coordinate, a size, a color, and a group, right? And whether or not it's visible. So there's all this information that's associated with a game object that are different. You have a couple of double values, and you have a Boolean value, and all these values that the compiler has to find a place for and find the right amount of place for. Constructors always have the same name as the class, and if there isn't a constructor for the class, the compiler will create one. But we are always going to write a constructor for our classes. And you can have, we'll see, you can have different constructors. You can have some that have no parameters and some that have some parameters. The information that's associated with the class, the data, that data is kept in what we call instance variables. Instance variables are the ones that define the values that you need to define the class or define the object, and those should always be declared as private, and so that there is no way anyone outside of the class can get to them just by using the dot notation. In order to get to them, you need to use methods, functions. Static functions are functions that are defined in the class but not associated with the object. If you are going to use a static function from another class, you have to give it the name of the class and the name of the function. And we kind of talked about this last week. So math is a library that's a class, and it has a whole bunch of functions. So see, we don't create a math object. We just use the function square root or any of the math functions, math methods. We just use it directly by saying the name of the class dot the name of the function. So those are static. Class methods are the ones that are associated with the class, and we will see a whole lot of different methods that you have in every class. For example, we had set x speed, we had set color, you had all kinds of class methods that were associated with the game object class, and we will write methods that are created for our own classes in order to manipulate the data and do something with the class. I'm going to talk about input in Java in a little bit. We saw that output, now we use system.out.print or system.out.println, and there's also system.out.printf to print a floating point number, where then you put in the way that you want the number to be printed. Input is kind of similar, and I'm going to show you an example in JGrasp in a little while that uses the scanner class. The example is here, but we're going to watch it and look at it in JGrasp. And then there's another example here of a class, but I'm going to give you an example of another class in a little bit. Okay, defining and using a class. So here's the example that I'm going to go over. So there are a whole lot of classes in the Java library that you can use, but usually when you're writing a program, you're going to create your own classes. And in that class, you're going to have data, information, and you're going to have methods that are functions that allow you to manipulate the data for the class. So here's an example of a dog class. Okay, so here's where you can define the class. You can decide what kinds of data fields do I need for the class and what kind of functions do I need for the class. And you can also define the types of constructors. These are the things that you use to initialize a variable that's going to be declared as type dog. So the data that we want associated with the dog class is we want a breed, that's a string. We want a color, that's also a string. We want a weight, that's a double, and an age, that's a double. And of course you can have more variables associated with the dog class, but for this example, we just have these 4 variables. Then the constructor. So if you're going to create a new dog, you would say dog, my dog equals new dog, right? Dog with open and close parentheses. Just like game object, box equals new game object. So there are 3 constructors here. One is just like that with no parameters. So you would just say dog with an open close parentheses. The next is dog, where you pass the pounds of the dog and everything else is initialized for you. And the third one is a dog, where you pass the breed name, the color name, and the pounds. So notice we don't have one that initializes the weight. We're going to just initialize the weight ourselves. Then we have, and I'm going to show you what these look like in a few minutes. Then we have some functions. So we want our dog to bark. We want our dog to walk, and we want to tell it how many miles we're walking. We want our dog to drink some ounces of water. We want our dog to pee some ounces. We want to be able to set the age of our dog in years, and we're going to have some other functions. One is ounces to feed, and then double years to dog years. So this one is static, meaning we're using years to dog years just to make a calculation inside the class, but you don't really need it as part of the dog. Okay, before I show you the main program, let's go down and look at the dog class, how you would define it. Okay, so right here are the instance variables for the dog. So we have string breed, string color, double weight, double age. And then we also have some other variables that we want to define in the class. One is ounces per pound, and the other is default puppy age. We're going to default the age to be a month. Okay, and notice this is taking 1 year, dividing it by 12, making it 1 month. So now we're going to have our constructors. So there are 3 constructors. Remember, there's one, we'll look at this one first. The one down here is the default new puppy. You don't pass any variables to it, and what it's going to do is it's going to give initial values for all of our data fields automatically. So when someone creates a dog, these data fields will be initialized to something. So we're going to initialize the breed to a mutt, the color to mixed, the weight is 2.5 pounds, and the age is the default puppy age, which is 1 month. Now we might want to have a dog that we construct where we give it a weight. So basically it's going to also create the mutt as the breed, the color is mixed, and now the weight, instead of year, the weight was set to 2.5. Up here, the weight is going to be set to the value that we passed to it, pounds. And then the age will be the default puppy age. Finally, we have a constructor that you can give the breed, the color, and the weight. So now we're passing a string for breed name, a string for color, and a double for pounds. Okay, so we set breed to breed name, we set color to color name, we set weight to pounds, and we set age to default puppy age. So you can create a dog and initialize that dog in 3 different ways. Okay, so if we go up here, this is our main program. We have some dogs. We have Rover, Spot, and Chip, and you can see we've declared them up at the top so that they are class variables. And then we're going to have a variable called dog years. So we have the normal public static void main string args, which is always our main. Okay, so we've already declared Rover to be a dog. So we don't have to declare it again. We don't have to say dog Rover. We can just say Rover equals new dog. Rover is a new dog that we know is a Labrador. It's going to be black, and it's going to weigh 60 pounds. So that one is going to use the constructor that has those 3 variables. The next one is Spot. We've already declared Spot up here to be a dog, so we can say Spot equals new dog 35. That's the one where he will be an unknown mixed breed weighing 35 pounds. And finally, Chip is just going to be a new dog with the constructor that just initializes everything for us. Unknown new puppy with default weight. Okay, so those are the constructors. We've created those 3 dogs. And then we can use the functions that are also in the class. So here we have a function called setAge, where you pass the years, and it's going to change the age of the dog. Age, remember, is defined up here, one of the class variables, and it's going to set the age to the years that are passed. We have another function here called bark. Bark will check the weight of the dog, and if it's more than 30 pounds, it's going to say woof, and if it's less than 30 pounds, it will say yip. Okay, we have another function called walk that we pass the miles, and we figure out the dog's weight depending on how many miles they walked. We're going to assume that the dog loses some weight when he or she takes a walk. So we're going to take the weight, subtract the miles multiplied by 1/10 of the weight, and then divide that by ounces per pound. Assign weight to that value. We have another function here called drink. When the dog drinks, it's going to gain some weight. So it'll take the ounces that they drink and divide it by ounces per pound and add that to the weight. If the dog pees, the dog's going to lose a little bit of weight. So you say how much it pees, and we're going to subtract a value from the weight. Then also we can return the number of ounces of food to feed the dog each day. So here they're going to say about a pound of food per 50 pounds of dog weight. So we can calculate the weight of the dog divided by 50 times ounces per pound. That's going to give us the ounces, and then if the puppy needs 50%. But puppy needs 50% or more, so if the age is less than 1, we're going to up the ounces by 50%, and otherwise, then we're going to return the ounces. So depending on if it's a dog or a puppy, we return different values. And so notice, remember, it is a function that you return a value, so you have to have return ounces here. And then finally, we're going to have a function here that's a static function that just calculates dog years to dog years, and it's just going to return years times 7. So we pass it the years, it's going to multiply by 7, and then you'll see how many dog years your dog is. Okay, so let's go back up to the main program. You can see how some of this works. So once we have Rover, Spot, and Chip, each initialized. So this is actually called, they are instantiated. They are each instantiated once we call the constructor. Now we can use any of the functions that are not static. We can use those functions for all of these dogs. And of course, we use them using the dot notation. So we can say rover.setAge and set Rover's age to 6. We can say spot.setAge and set Spot's age to 6. And remember, then we're not changing Chip's age, so Chip's age is still 1 month. Okay, so if we were to print Rover is, and we print Rover's age years old, we would see Rover is 6 years old. If we were to print Spot is and Spot's age years old, we'd get Spot is 4 years old. And if we print Chip's age, we will get Chip is, and it will be 1 month old instead of a year old. Okay, so then we have the function play with dogs. Play with dogs is just a function that we've defined in the main. And what that does is it's going to have Rover bark, Chip bark, it's going to walk Spot, Spot's going to drink, Spot's going to pee. Okay, and then we can print some information. So Rover now weighs. So remember, if Rover walked or drank, then Rover's weight would change. Rover didn't walk or drink, so his weight should be the same. Spot, however, Spot walked and drank, so Spot's weight is going to be a function of having walked and drunk, and peed. So he did everything. And then Chip didn't do anything but bark. That doesn't affect his weight either. Food ounces needed, we're going to calculate total food needed, and that's another one here that we have a function that what it does is it just returns the ounces to feed plus, so Rover's ounces to feed, Spot's ounces to feed, and Chip's ounces to feed. So we find out how much food we need for all 3 dogs in a day, and then we can calculate the dog years. And if we're going to use the function years to dog years, we have to actually use the dog class to call that function, and we can pass it Rover's age. and then we can find out what the dog years are, and then we can print the dog years. Okay, so that's a lot here, but I'd like you to sit down and go through it and follow what we're doing and practice calling some of the functions or some of the methods. Okay, let's look at some definitions here. The constants are defined at the top, just like we did with other classes. Data fields, the instance variables, we have them all also defined at the top as class level variables. The constructors, we had 3 different constructors. Notice there is no return value on a constructor. You just put the name and whatever parameters, dog, dog, and dog. There's no void, there's no return type, it's just the name of the function. And constructors are the only functions that, 1, have the name of the class, they have to be the name of the class, and 2, they don't have a return type associated with them. And remember that the constructor needs to initialize all of the instance variables for an object that you've declared as a variable of that type. Method functions, again, we have all the functions and we use the dot notation. If we want to call a function, we have to first declare a variable of that class type. To create an object, we have to instantiate it with its constructor, and then we can use the functions using the dot notation. Notice that when we're inside the class, we don't need to have any dot notation. We can just access all of the variables without having an object associated with it, because it's defining the functions that will then later be associated with an object. There are 2 types of methods. They are called accessor methods and mutator methods. Accessor methods or getter methods are methods that access an object but don't change it. So sometimes you will want to just get the value of one of the class's instance variables, and you will use what's called a getter method to do that. So say we wanted to get the weight. We want to see what the weight is of a dog. We can create a function called getWeight, and then you can use that function outside of the class to see what the weight is of a dog. A mutator method or setter method is a method that actually changes the state of an object, meaning you're going to change the value of one of the instance variables. So say you want to change the age of one of the dogs, you could have a function called setAge. SetAge is a mutator method. You give it a new age and it will literally change the value of the instance variable for that dog. So remember that you have accessor or getter methods, mutator or setter methods, and we will be using those in our programming projects. Okay, again, we already talked about calling static methods versus instance methods. Remember, instance methods, you need to create an instance of a class, and static methods, you just use the class name in order to call the function, like for math. Remember, you also have to import the class if you're going to use class static methods, and then you can use them. So if you're going to use math, you need to import the math library, just like we imported the random library in our last programming assignment. Just as a convention, we start all of our class names with an uppercase, and all of our variables start with a lowercase. And so here you have shelter or cat, those we know are names of classes, and then my shelter and my kitten are names of variables. Okay, there's some additional features that are now in Java that we didn't have when we used code 12. There are more types of variables. Instead of just int, double, boolean, string, and game object, we now have, for numbers, we have a byte, a short, a long, an int, a float, and a double. So what's the difference? The difference is the amount of space that's given to the variable when the compiler compiles the code. We will mostly use int and double still, but there will be times that you will have to use some of these other variable types. There's also a variable called a char or a char. It's a single character as opposed to a string that's a string of characters. So those aren't used again as often. If you do have a char or a char variable, instead of like a string you put in double quotes, you would put that value in single quotes and it only has a single character. You can get a lot of information on Java and all the different data types if you go to the Java website here, and when you do that, it'll show you how to use every single class that's in the library and all the functions that are in each of the classes and parameters they need and all of that. So you can always click here. I'll click on that in a minute. Just one other thing is there's something called a switch statement that we aren't really going to get to, but you will in CS13. It's kind of like an if, else if, else if, else if. Instead of doing that, it's a simpler way to have that kind of control using a switch statement, which you can also look at here. So if we go to this is telling us all of the different data types. You can then find everything here: Java syntax, Java operators, the math, Booleans. You have all these different methods, all the different classes. So you can use this as a reference, this website. Okay, now I'm going to show you an example of using input in Java. So if we want to input values, we know how to do it. We know how to output now, but here's how you would input. You would have to import a library called the scanner library. So you import java.util.scanner. And then this is my class, input demo. It just consists of a main function. What you would first do is you would declare a scanner variable. So you can have scanner with uppercase, that's the name of the class. The name of the variable, we'll call it scanner. We have to instantiate it with the constructor, so we say equals new scanner, and we're going to give it the parameter system.in, which means it's just going to take input from our keyboard. There are other things you can read from a file. There's other ways that you can do input, but system.in is our keyboard. Then here it says we're going to input the name and age from the console. So you can print, because you always want to prompt your user so that they know that you're waiting for input. Enter your name, and then we're going to assign a variable called name that's a string to the input of scanner.nextLine. Scanner.nextLine basically reads a string. It reads everything until you hit enter. Okay, so whatever I enter, it's going to read every single character until I hit the enter key, and that's going to go into name, and then we will print name. Then we're going to ask for the age. So what we're going to have a variable here called age that's of type double, and that's going to use the next double. So here we use next line, here we use next double. It's going to look for a double value, a floating point value, and read that in and assign that to age, and then print age. And then we're going to say, what is your favorite number? And so now there's also an integer one, scanner.nextInt, and that's going to look for an integer. And if you type a whole bunch of integers separated by spaces, it's just going to get the next one. So, but if you had another scanner.int and you had two numbers on the same line, the first scanner.nextInt will get the first number, and then the next one will get the next number. Okay, and it'll print it. So we have scanner.nextLine that reads in characters. We have scanner.nextDouble that reads in a floating point number. We have scanner.nextInt that reads in an integer. since it's reading it in, we always have to assign it to a variable. So let's see what happens when we run this. So we're going to see it run down here, and it's going to ask for our input down here as well. So I click on the run. So see down here, enter your name. So I'm going to enter my name, Susie, and it printed Susie right here. Then it printed enter your age. So it's asking me for my age. Okay, and it prints my age as a double. Then it's going to ask for my favorite number, and it prints my favorite number. So that is how you input, and we've also done some outputting. Remember, you can then go back up and down over here. You can scroll to see your input and output. You can also clear your input with the clear, and that will clear it all for the next time you run. Now when you're running programs, you can always put print statements in to see what, to help you test your programs. So that's a good thing to do. And remember that when you're putting input, you want to always prompt your user for what they need to input into the program. Let's look at the programming assignment for this week. It's program 11, and what you're going to do is you're going to create a bank account class. So I want you to declare private instance variables. That means you need to use the term private. You need to say private, the type, and the name of the variable. You're going to have one that's your full name, an account number, randomly calculated 5-digit number, and then the account balance, which is the current account balance. So remember, those are private, so they can only be accessed by the actual class. If you're running a program in your main, you can't access these values unless you have a function to do so, a method to do so. We're going to have two constructors, one that has no parameters, and we tell you what to initialize to here, and the other with two parameters that give you values to initialize. So now we're going to have some set and get. So usually we call a mutator method which changes a value. We use the word set in it. So set name, we might have others. There isn't another set here, but if we were going to change another value, we'd call it set. So set account number, set balance, and then we're going to have get name, get account number. Okay, those are going to get balance. Those are going to be accessor methods where we get the values of the instance variables. We're going to have a function called generate account number that's going to randomly calculate a 5-digit number. So guess what? You'll have to use the random class that we used last week. You're going to have, again, the get account number. That's just going to return the current account number. You're going to have a deposit function, a withdraw function, a get balance, and a print receipt. Okay, the withdraw function, you have to make sure that you're not withdrawing more money than the person has in their balance. Okay, so here you go. Once you create your class, you're then going to have a main function that is in the same class up here, but it's a main function, and you're going to do all these 13 steps. So it shouldn't be too difficult. I hope it's straightforward, but we're practicing creating a class. We're practicing doing it in JGrasp and regular Java. I know the Java editor that's in JGrasp isn't as nice as Sublime Text. We have to make sure that you indent correctly and have your brackets line up. And I actually am going to make sure that you do, okay? If things aren't nicely lined up, then that's not good, and I can take off points. Also, it would be really nice if you put comments in your code to tell me what you're doing. Okay, so you should comment your code. It should be formatted correctly the way we've been formatting the code already. So if you have any questions, please feel free to email me. Also, you can come to my office hours on Thursdays from 4 to 5. Or if you want, we could set up a Zoom meeting at a time that works for you. So have a great week. I'll talk to you next week.